Warning: this video contains clips and excerpts of a humorous nature not normally found in math class. These are intended to fight the adolescent condition known as short attention span, found heavily in the modern teen, especially when in school. The only thing you should attempt at home is the math. The rest, you just laugh at.
Hi, welcome back to AT Math. Today it is 6-6, solving systems of linear inequalities. Why, this is going to be easier than running a trick play in a Little League football game. Okay. Now this here is the same thing as we did before, but instead of shading one area, we're just simply doing for two lines. Take a look here. If I have y is greater or equal to negative 2x plus 1, I start at plus 1. Then because it's negative 2x, I go down 2 over 1, down 2 over 1. So I have my line, and since it's greater than or equal to, I make a full line because it's equal to, and I shade above. The other guy, y is greater or equal to x minus 1, I go down 1, and then because it's x, it's the same as 1x, or 1 over 1. It's going to go up 1 over 1, up 1 over 1, and shade above. Therefore, I have these two combined, and inside this area is my solution. Because both overlap, notice how there's a different color here. Anything inside here will solve or satisfy both sets, therefore it will be a solution. This is my crude drawing to prove that, and there we have it. Let's do a you try it this time. Go ahead and do one line shade, do the other line shade. Let's see if you have matches mine. I went ahead and put y is greater or equal to negative 4x plus 2, so I went up 2, and then down 4 over 1, down 4 over 1, and shaded above. Remember, I used a full line because it's equals. And then here I went down 1, up 3 over 1, up 3 over 1. I shaded below because it's less than. Anything inside the two where they overlap will be a solution set. Now the same with this, but with dotted lines. Why dotted? Because there's no equals. Because there's no equals, it's not part of the solution, it's just the border of the solution. So y is greater than negative 2x plus 3. So I go up 3, then down 2 over 1, down 2 over 1. Dotted line means I'm where the action is, but don't include me. And then greater than, so I shade above. Well, okay. Then the other guy started at negative 2. Then up 4 over 1, up 4 over 1. Dotted line because I'm not equal, but greater than, so I shade above. This slim area here is going to be where they touch both, so it's going to be a solution of both. Now the next stage is to make it into y equals mx plus b first. So all I got to do here is take this guy, and for the first one, instead of plus 8x, I'm going to minus 8x. Minus 8x to one side, minus 8x to the other, just like that. Then, if you notice, I still have 4y. So I'm going to divide by 4 over here, divide both of these by 4 over here. And I get y is less or equal to negative 2x plus 3. This guy was conveniently already a y equals mx plus b of sorts. It wasn't equals, but it's still in the right form, so I can keep it as it is. Now I graph. Y is less or equal to negative 2x plus 3, so I go up 3, down 2 over 1, down 2 over 1, shade below, full line because it's equal to. Then this guy, y is greater than 1/2 x minus 2, you go down 2, up 1 over 2, up 1 over 2, dotted line because it's not equal, shade above. This area here where it's going to hit both will be the solution set. You try. Let's see what you got. I started with this, and I went ahead and combined and moved stuff around until I got y equals and y equals. And you could either have for this one, y is greater than 1/4 x minus 3, or y is greater than 0.25. But for graphing purposes, I would keep rise over run myself, and I would definitely keep rise over run on this one. Notice here, y is less or equal to negative 1/3 x plus 2. So you went up 2, down 1 over 3, down 1 over 3. And I am shading below, so that or less. And this here, y is greater or equal to 1/4 x minus 3, go down 3, up 1 over 4, up 1 over 4. Although This actually was a bit of a mistake because this is not. This is not a dotted line. I mean, it should be a dotted line, not a full line. So let's go ahead and just make a quick fix on that. That'll have to do. And we'll save that for posterity. All right. Take a short break.
What?
I saw that movie last night.
I'll save you from the screaming sheep. We've been doing it every day for the last I don't know how many days. So, whoa, there's your sheep for you. So a surf shop makes the profits given in the table. The shop owner sells at least 10 surfboards and at least 20 wakeboards per month. He wants to earn at least $2,000 a month. Show and describe all possible combinations of surfboards and wakeboards that the store owner needs to sell to meet his goals. List 2 possible combinations. So if you notice here, he intends on making $150 profit on a surfboard and $100 profit on a wakeboard. So let's go ahead and pick the paragraph apart. At least 10 surfboards, so X is greater or equal to 10, and he's going to sell at least 20 wakeboards, and he wants to earn at least $2,000 a month. What you want to do is there's a couple things happening. First of all, he wants to make $150. Well, let's see here, $150 on his X. That should not be 1,000. That should be 100. Boy, it's just my day to make mistakes on this lesson. I'm so glad I'm going over this here. So it should be 100Y, not 1,000. Excuse me. So 150X per surfboard, 100Y for each wakeboard, and 2,000 my profit. By the way, it doesn't matter again if I made the 150X or if I made the 150Y. It will be fine, but if I go up here and put X says for 10 surfboards, then I have to have the X for the surfboards here. In other words, if I start with X as surfboards, it has to stay with surfboards, and if Y starts with wakeboards, then Y has to be wakeboards down here. Now if you take a look, I've noticed that if I have X is greater than 10, which is this way, and Y is greater than 20 is this way, this shaded part here shows me how to graph it. So basically he wants to hit somewhere inside here for his possible solutions. Now before we stop real quick, why does he care to do this? Because as a business owner, you of course want to schedule or plan for a profit. You don't just want to throw some stuff on the wall and say, okay, I hope someone buys something, because those are the kind of owners who are out of business in about 6 months. What you want to do is you want to say, I have a very good idea how many customers I'm going to have and what they're going to want to have. And based on what you plan they're going to buy, you want to stock that. Now, you won't know for sure, of course. You might have to do a little research and a little bit of good guesstimation. But the idea is to have your store stocked best you can to get those initial sales. And by the way, most stores and restaurants do have trouble the first year. So if you do ever decide to buy into a restaurant or make your own or start a store, make sure you have some extra capital lying around so you can get 6 to 9 months of lean times when you don't have many customers before you build your customer base. Anyway, with that lecture over, we are done.
Burmese pythons are an invasive species from Southeast Asia that have found a home in the Florida Everglades. These large constrictors compete with American alligators as top predators. For the first time in history, these two top predators are battling for the same resources. Larger alligators with their powerful jaws have a distinct advantage over the pythons. The alligator holds onto the python with power exceeding 2,000 pounds per square inch. It is next to impossible for the python to escape this hold. Nevertheless, the alligator gives way to the python. After an exhausting battle that lasts for hours, an unusual twist of fate occurs. On rare occasions, the Burmese python is able to intimidate the alligator into a retreat.